Okay, today we would like to present on a question that we already choose, and the explanation on the subject DFN 30073 switching and routing essentials, chapter 4 switch networks. But for Sir Muhammad Adib. Okay. This is our group member, and the first one is me, Muhammad Irman, and the second one is Muhammad Yad Faiz, and the third one is Aaron Mangi. For the first one, for the first question, what are the two criteria that used by Cisco LAN switch to decide on how to forward internet frame? So the answer is the ingress port and the destination MAC address. The explanation: this is because the Cisco LAN switches use the MAC address table to make a decision of traffic forwarding. The decisions are based on the ingress port and destination MAC address of the frame. The ingress port information is important because it carries the VLAN to which the port belongs. For the second question, refer to the exhibit. Consider that the main power has just been restored. PC3 issue a broadcast IPv4 DHCP request. To which port will SW1 forward this request? The answer will be to port F01, F02 and FA03 only. On the third question, what is one function of a layer 2 switch? The answer is it determines which interface is used to forward a frame based on the destination MAC address. For the explanations, a switch will a MAC address table of MAC addresses, and it associates port numbers by examining the source MAC address found in inbound frame. They also forward a frame onward. Then the switch examines the destination of the MAC address. It looks in the MAC address for a port number associated with the destination MAC address and send it to the specific port. If the destination MAC address is not in the table, the switch forwards the frame out all ports except the inbound port that originates the frame. For the fourth question, refer to the exhibit. How is a frame sent from PCA forwarded to PCC if the MAC address table on switch SW1 is empty? For the answer is SW1 float the frame on all ports on SW1, including the port through which the frame entered the switch. For the explanation, when a switch power is on, the MAC address table is empty. The switch will the MAC address table by examining the source MAC address of incoming frame. The switch forward based on the destination MAC address found in the frame header. If a switch has no entries in the MAC address table, or if the destination MAC address is not in the switch table, the switch will be forward the frame out all ports except the port that brought the frame into the switch. For the fifth question, a small publishing company has a network design such that when a broadcast is sent on the LAN, 200 devices receive the transmitted broadcast. How can the network administrator reduce the number of devices that receive broadcast traffic? And the answer is they segment the LAN into the smaller LANs and route between them. This is because by dividing the one big network into the two smaller networks, the network administrator has created two smaller broadcast domains when a broadcast is sent on the network. Now, the broadcast will only be sent to the devices on the same internet LAN. The other LAN will not receive the broadcast. For the sixth question, refer to the exhibit. How many broadcast domains are displayed? For this answer, it will be 8. This is because a router defines a broadcast boundary. So, every link between two routers is a broadcast domain. In exhibit, 4 links between routers make 4 broadcast domains. Also, each LAN that is connected to router is a broadcast domain. The 4 LANs in the exhibit result in 4 more broadcast domains, so there are 8 broadcast domains in all.
Good day to everyone. My name is Muhammad Yas Faiz, and I'm going to explain question 7 until 11. On question 7, which solution would help a college alleviate network congestion due to collision? The answer to the question is a high port density switch. The explanation to this answer is switches provide microsegmentation so that one device does not compete for the same Ethernet network bandwidth with other network device, thus practically eliminating collisions. A high port density switch provides very fast connectivity for many devices. Question 8. Which network device can serve as a boundary to divide a layer 2 broadcast domain? The answer is router. Explanation to this is because layer 1 and layer 2 devices, LAN such as LAN switch and Ethernet hub, and access port device do not filter make broadcast frames. Only a layer 3 device such as router can divide a layer 2 broadcast domain. On question 9, what is the destination address in the header of a broadcast frame? The answer is just ff/ff/ff/ff/ff and /ff. Explanation to this answer is because in a layer 2 broadcast frame, the destination MAC address contained in the frame header is set to all binary 1. Therefore, it becomes the format of just f of the given address. The binary format in 11 in a hexadecimal is 0001, 0001, 255.255.255, 2.255 and 0.0.0.0 are IP addresses. On to question 10. Which statement describes a result after multiple Cisco LAN switches are interconnected? Answer to that is the broadcast domain expands to all switches. Explanation to this is in Cisco LAN switches, the microsegmentation make it possible for each port to represent a separate segment, and thus each switch port represents a separate collision domain. This fact will not change when multiple switches are interconnected. However, LAN switches do not filter broadcast frame. A broadcast frame is flooded to all 4 ports. Interconnected switches form one big broadcast domain. On question 11, what does the term port density represent for an Ethernet switch? The answer is the number of available ports. Explanation to this is the term port density represents the number of ports available in the switch. One rack unit access switch can have up to 48 ports. Larger switches supports up to hundreds of ports.
Hi guys, my name is Ermangyara Frederick. Now I will continue with the question 12 until 16. A network designer must provide a rationale to a customer for a design which will move an enterprise from a flat network topology to a hierarchical network topology. Which two features of the hierarchical design make it the better choice? Okay, the answer is easier to provide redundant link to ensure higher availability, and simpler deployment for additional switch equipment. Here, now we will see the explanation. A hierarchical design for switches helps network administrator when planning the deploying a network expansion, performing fault isolation when a problem occurs, and providing resiliency when traffic levels are high. A good hierarchical design has redundancy when it can be afforded, so that one switch does not cause all network to be down. Question 13. What is a collapse core in the network design? The answer is a combination of the functionality of the distribution and the core layer. Explanation. A collapse core design is appropriate for a small, single building business. This type of design uses two layers, that the collapse core and distribution layer consolidated into the one layer and the access layer. Larger businesses use the traditional three-tier switch design model. Next, question 14. What is a definition of a two-tier LAN network design? The answer is distribution and core layers collapse into one tier and the access layer on a separate tier. Explanation. Maintaining three separate network tiers is not always required or cost efficient. All network design require an access layer, but a two-tier design can collapse and distribution and core layers into one layer to serve the needs of a small location with few users. Next, question 15. What is a basic function of the Cisco borderless architecture distribution layer? The answer is aggregating layer 3 routing boundaries. The explanation. One of the basic functions of the distribution layer of the Cisco borderless architecture is to perform routing between different VLANs, acting as a backbone and aggregating campus blocks are functions of the core layer, providing access to end users devices is a function of the access layer. The last but not least, which two previously independent technologies should a network administrator attempt to combine after choosing to upgrade to a converged network infrastructure? The first answer is user data traffic, and the second answer is VoIP phone traffic. Now we will see the explanation. A converged network provides a single infrastructure that combines voice, video and data, and log phone, the user data and point-to-point video traffic are all contained within the single network infrastructure of a converged network. So guys, we have come to the end of the show. So hope that our explanation is very clear on this chapter, which is chapter 4, switch network. So if you have a question on this chapter, you may ask it. And that's all from us. Thank you and bye bye.